In this video, I am going to show how to perform the data mining task using the different tools. In this video, I am going to show the tool WEKA and also the RapidMiner. And there's three parts in this video. The part 1, it will be the tutorial on the WEKA. Part 2 is a tutorial on RapidMiner. However, in part 3, it is a comparison between the WEKA and also the RapidMiner. And now, first, we move to part 1, the tutorial on the WEKA. And my title is A Comparison of Classification Model Performance on Dermatology Dataset. And we choose Random Forest, J48, and also the name Bayes. This is the dataset description for my dataset. This is the name, dataset characteristic, attribute characteristics, and the source, date donated, publication, the URL is the website where I get this dataset. Now I will show you my dataset in Excel, and this is my dataset. This is the attribute, and this is the class distribution. Now let's move to WEKA. First, launch your WEKA and go to Explorer. Then we have to import our file, so go to Open File and choose the location of the file to open your file. Since my file is in CSV form, so I choose CSV and select and open my file. And now my file is imported. For current relation, we can see the relation, which is the name of your dataset and the number of instances of my dataset is 366, and also attribute in your dataset and is 35. And this is the name, the list of my attribute in my dataset. If you want to remove some unrelated attributes, you can simply just select and then remove, and they are gone. But here I am not going to remove my attributes, so I undo. And beside the panel at the right panel is selected attributes for each from your attributes. For error mark, the missing is 0, and the type is numeric, and distinct is 4. Distinct, which means the different value in your attributes in the data set, and it's 4, and it also shows some basic statistics and the value. The statistics it shows minimum, maximum, mean, standard deviations. You can visualize your attribute in a histogram for each, or you can visualize all in a window. However, for the classified, it needs a nominal input, but my input is numeric. So it's unable to predict your numeric attributes, and it needs nominal inputs. So we have to do this filter to make your numeric input to nominal. So we back to WEKA, and then we go to filter and choose filter unsupervised attribute, and we have to select numeric to nominal, then apply. Now your inputs has changed to nominal, so we can begin our model test performance of different models. So go to classifier, and first we are going to show is J48. We go to trees and we choose J48, and then we click start. This is the output of a result. This is the description of your dataset at the upper part. This is the relation, the name of datasets, the number of instances in your datasets, and the number of attributes in your datasets. And this is the list, and this is the tree, but in a text, the form of text. So it has a number of lists is 30, the size of tree is 40, and the time taken to build the model is 0.01 seconds. And this is the summary. We focus on the correct classified instances and the incorrect classified instances. For here, the correct classified instances is 94.5355%, and the incorrect classified instances is 5.4645%. And also show the detailed accuracy by the class, which is it will show TP rate, true positive rate, FP rate is a false positive rate, precision, recall, F measure, ROC error, and also the class. And this is the average for each column. This is for TP rate, this for FP rate, and this for precisions, and so on. And here is also show the confusion matrix. For tree J48, we can show the tree not only in the text form, we can visualize it. We just right click and visualize tree, maximize, and fit to screen. We can visualize the tree not only in the text form. So now let's move to another model, which is the random forest. Choose random forest and then click on start. And it takes longer time and it's processing. Now it's done. And same, this is a description of your data sets, the number of instances and the attributes and the list. Here we focus on the correct classified instances and incorrect classified instances again. And the correct classified instances is 95.082%, and the incorrect classified instances is 4.918%. And this is the details for the TP rate, FP rate, precision, recall, F measure, ROC error, and also the class. And this is the average for each column, and it shows also the confusion matrix. For this, we can right click and visualize classified error. And the X is a class distributions, and the Y is a predicted class distributions. We can click on it for the information, instance informations, or you can adjust with the jitter, or you can save. Just type a file name and click save. So next, let's move to the last model, which is the naive Bayes. Click Bayes and choose naive Bayes and then start. Here is the description of a dataset, instances and the attribute and the list. And for naive Bayes, it shows a more detailed for the information, and it will break each attribute and also the class distribution of the class. Since we have 6 classes for erythema, so means the ranking with 3, mostly they will get the disease for the class 1, which is 42%, and so on. Also same for the others rankings. For the attributes, they are the same. So next, let's move to the accuracy. For this case, the correct classified instances is 97.267% and the incorrect classified instances is 2.7322%. And the detail here, the TP rate, FP rate, precision, recall, F measure, ROC error, and also the class. And this is the value for each class. And this is the average for each column. And this is a confusion matrix. So let's compare 3 of this model. For J48, the correct classified instances is 94.53%, and for the 3 random forests is a 95.082%, and the naive Bayes is shown the highest, which is 97.267%. So let's compare, so you will see more clear if we compare in the table is this table, and table we can see the comparison result from 3 of the model with J48, random forest, and also the net Bayes. For J48, the correct classified instances is 94.5355%, and the random forest is 95 something, and for the Bayes is the highest. We can see among 3 of these is 97.267x, and it's also same for the average TP rate, FV rate, precision, recall, T measure, and ROC for 3 of the models, J48, random forest, and the net Bayes. And here we can see for the TP rate, the net Bayes still show the highest among 3 of these, and the lowest is a J48, and random forest is between J48 and also net Bayes. So in conclusion, net Bayes give the best performance with the highest accuracy of 97.27% among these 3 models. And this is the end of a tutorial of part 1 on WEKA. And next, let's move to the part 2, another tool of RapidMiner.
Hello everyone, let's proceed to part 2 tutorial on RapidMiner. Here, the title are the same, a comparison of classification model performance on dermatology dataset, which I will use the same dataset. And the classification models will be used also the same, Bayes decision tree in RapidMiner, but in WEKA it is J48 and random forest. So let's open the RapidMiner tools. Here the RapidMiner tools. In home we show how the tutorial, new process open, and we click the design to do the process. First of all, we need to import our file, dataset file. I save it in CSV file, so I will import in CSV file. Here we show in comma. To change it, go to column separation, click comma. Here it will show in table, click next. Here is just to name the attribute, but there should not be named in this dataset. Just click next. And here it shows that our dataset have contained 0 errors. And I will not change the data type and also the attributes. Just proceed. And here I will choose data in local library data to save the file in dermatology. And then I can click finish. It will show the result of the table. It can contain 366 examples and 35 regular attributes. In RapidMiner, it's called example sets for dataset. So the statistic, it shows the data type, which is integer, missing attributes or values. In statistic, when we click the attribute, it shows the chart of the attributes. The minimum of the attribute, maximum, average, and deviation. As we can see that all the data in this example set are integers except for age, which is polynomial. So let's go to the process. First of all, we need to do is pre-processing technique. As we will do the classification methods, we need to change the numeric to nominal. The data type of the example set I shown you before is integer, so we need to change it to nominal. First, we drag the data file that we have loaded before into the process and drop. And then go to the here, data transformation, type conversion, do the numerical to polynomial, drag and drop. After that, in RapidMiner, if you see that all the attributes are regular before, there is no special attribute, we need to have one special attribute to distribute or classify the attribute. So we set the attribute name, which is class distribution, and its target role will become a label. So that's all, and then we can link it. So we need to do the evaluation for each model to see the accuracy. I will choose cross validation in this tutorial. So link it for this validation output. You need to link everything so that it will show the result for model, training, and average. So here we double click the validation operator. It will show another screen. In this screen contains training and testing. For this training, we need to insert the model operator. I will choose Bayes first as our first classification model, and as usual you need to link it. And for testing, we just need to apply the same operator, which is I will choose apply model, and for performance I will choose performance classification, and links all this. This is in the validation operator. So we back to main process. After that, we click run. It will show in result the accuracy of the Bayes for cross validation is 96.45%. Here is the confusion metric for Bayes, and here is the description for Bayes. And if we choose that special attribute class distribution, it classify it into the class distribution, which is for class 2 it contains 0.167, class 1 0.306, and here in distribution table it shows the detail for each of the attribute. So you can see the detail of the attribute with the special attribute of class distribution, and we also can see in the chart form. Okay, that's all for Bayes. Let's proceed to the next model. We perform all this model in the validation operator. Double click and show this Bayes. We change it to another model, which is I will use decision tree. Let's change it back to main process and run. Here, the accuracy of cross validation for decision tree are 90.22%. This is the confusion metric and performance vector for decision tree. Here is the description for decision tree. We show the graph of the decision tree and in the form of description. All the last of the model, we will use a random forest. Okay, we have changed it back to 2 and 1. Here the accuracy are for cross validation in random forest are 77.37%. Here this confusion metric for random forest, and for random forest it split the tree into 10 model. So we have model 1, model 2, model 3, model 4, model 5, model 6, model 7, model 8, model 9, and model 10, and here in description form also we can display it. So that's all for the tutorial. So I will explain to you the comparison result accuracy between the three models in RapidMiner that I have performed, which is Naive Bayes contain the highest percentage, which is 96.45% compared to decision tree and random forest. So Naive Bayes is suitable model to use for the dermatology dataset that I have chosen. So let's proceed to part 3, comparison on WEKA tool and RapidMiner tool. I will explain to you the comparison result accuracy on WEKA and RapidMiner first. In WEKA, for Naive Bayes, it is 97.2678%, and for RapidMiner, I have stated before 96.45%, which is in both tools. This is the highest accuracy for both tools. So in both tools, the dermatology dataset will be used for Naive Bayes model. So dermatology dataset will be applied in Naive Bayes model. It's suitable to apply here, but different from for decision tree or J48 in WEKA and random forest. In WEKA, decision tree is the lowest, but in RapidMiner, random forest is the lowest, and it's a bad percentage because it's below 90%. So I think the WEKA tool is very accurate compared to RapidMiner accuracy, and I will show you also that in WEKA it is have detailed accuracy by class, but not in RapidMiner. It is just contain the confusion metric and the accuracy. So WEKA is more detailed output that have been shown. And I also our opinion that WEKA is more simple to perform, because you just need to choose and click it. Choose and click the the method that we want to use. See, if we show the detailed accuracy by class, but not in RapidMiner. But in RapidMiner, I think the advantage of RapidMiner is we can see the relation from the operator to another operator, so that there is no confusion, or we can see the flow of the activities. But we prefer WEKA because it is simple and easy for us to see the data. And RapidMiner also doesn't have a detailed data, and it's hard for us to see it. And I think that's all from us for this video tutorial. Thank you for watching.